Good morning, everybody. Let's talk about what is a trait. So today's lab, we're going to actually try to figure out how in the world we go from DNA to an actual trait. And a trait is something like your eye color, your hair color, your ability to roll your tongue, the trait of having dimples, freckles are traits. So how in the world do traits actually get made and formed? Well, we have to start first by looking at DNA. So you are going to start from DNA and you're going to go all the way through the process to make a protein. A protein, which we'll learn a little bit more about later, is actually what creates the traits that you have. So you are going to follow through this little lab activity and you're going to start by constructing the DNA. So it says use the following Google drawing. If you click on here, it's going to ask you to make a copy. You're going to make a copy and it looks just like this. Okay. If we were in class, we would actually have cards for you that we would lay out on a lab table. We'd have blue, yellow, orange, green, and kind of this purple pink color cards. And you would be using them to actually go through this lab. Because we can't physically have the cards in front of us, you guys are going to create, basically drag these little cards around and create the lab in front of you on a Google drawing. So we're going to start here with strand 1 of the DNA. That's this blue strand right here. It's already been built for you. So what you're going to do is you're going to take that strand of DNA and you are going to record it in your lab right here where it says top strand. Pretty simple. It's already highlighted in blue, so you know that you're going to record all the blue information here. If you take a look, DNA is always written in groups of 3. We call those codons. So DNA, again, always read in chunks of 3. It makes life a little bit easier. Think about when you were a little kid and you had to memorize your phone number. It was easy to chunk it. First 3 for your area code, next 3, and then the next 4. We always chunk things up. That's why your social security number is chunked the way it is. It's easier to remember. So you're going to record the top strand, and then you're going to drag these cards around over here until you believe they match up underneath the strand they represent. Now for DNA, A always pairs with T, G always pairs with C. Okay, so for instance, this card is ACT. So you know the opposite of ACT has to be TGA. So I'm going to place it right underneath the card that matches. Okay, and I'm going to do that with the rest of the yellow cards. Once I'm done, I'm going to record that information on my lab document right here where it says bottom strand and is highlighted in yellow. Part 2. This next process is called transcription. We call it transcription because you are literally scribing or rewriting DNA into a new code called RNA. You did this yesterday when I sent you off to breakout rooms and you had to figure out how to pair and match the cards up. You learned something. There was one letter that disappeared, and that was T. T was replaced by a U whenever you played with RNA. So A would start to pair with U's. Okay? C's and G's still paired with each other. So you're now going to go through and you're going to take a look at the DNA strand in yellow, and you're going to try to find the complementary strand for RNA. For instance, let's take a look at this one. ACT, A would pair with T normally if it was DNA. But since we're looking at RNA, A is going to pair with U, C is going to pair with G, and T is going to pair with A. So I'm looking for UGA. So I scan through the cards. Here's UGA. So I'm going to drag that and put it underneath the ACT. And I'm going to continue with all of the yellow cards and place them right under their match for the line above. Okay. I'm going to type that information down in the lab document right here for number 4. So now that you've just done transcription, transcription still takes place in the nucleus because remember, DNA cannot leave the nucleus. It is super special. We don't want it to go anywhere. So this process happens in the nucleus. RNA then is able to travel from the nucleus and leave and go to the ribosome. We call it mRNA because the M stands for messenger. It carries the message of the DNA from the nucleus to the ribosome. So that's how we rewrote it. We rewrote it into RNA so that we can take that message and travel to the ribosome. Once in the ribosome, there's some questions for you to answer based off of this little reading right here. Once in the ribosome, you are now going to translate that code into a new language. Okay, if you guys have ever had to do this in Spanish or French class, you take an English word and you translate it into that other language. So we're going to translate it into amino acids. To do that, we have to go through a couple of steps. There's the tRNA strand and there's the amino acid strand. And this actually should be green. So the tRNA strand are the green cards. The green cards have to be the opposite of the orange. So UGA, the opposite of UGA would be ACU. So ACU. ACU will go right underneath the orange. Oops. And technical difficulties. Once we drag that over here, oh boy, you see that it actually has this little phrase underneath it. That phrase underneath it says stop. UGA actually codes for the amino acid to stop this process. It's kind of like when you get to the end of a book, you're going to stop reading. It's telling the cell, okay, once we've read out this entire code, stop at this point, don't go any further. You have now made the protein that creates the trait. So if we look down here, there actually isn't anything for the stop codon. But if there was, we would then attach this underneath. Take a look at this one. It's GLU. That stands for glutamine. So we would place this one underneath because it would pair with that one. So what you're going to do is you're going to do a couple things. You're going to first figure out which green card goes below the orange. And then you're going to put the purple amino acids, matching them up with the tRNA. Once that's done, you're going to record the tRNA strand and the amino acid strand. A chain of amino acids makes a protein, and you have just created a trait. So you've finished the lab activity. So go ahead, go through the lab activity. You can always use this video to help you if you get stuck or confused, and then finish things up. Okay, have a great day.